Welcome to the show, everyone, and today I will be talking to you about oceans. Now, what is an ocean exactly? Well, the ocean is all the blue stuff that you see on Earth. Pretty simple? Well, it's not just that simple. The ocean is made up of many creatures, different properties, not the local freshwater lakes, not the little glass in your water you may or may not be drinking. Only Earth has such a special thing such as oceans, or just water in any sense. We don't know of any other planet that has it in the entire universe. Though we may think there are some. You may think there's a lot of water even here just in Florida, but in reality, the global ocean makes up 97% of all the water on Earth. Pretty wild, right? The Pacific Ocean shares most of this water, as it is the largest in the entire world. Despite being so vast, the ocean is only 1/4000th of Earth's total mass, and it only contains 1/800th of the total volume of Earth. Makes you wonder, what else is really below Earth? That's a different story. This one is about oceans. There are 5 main oceans that are each a piece of the global ocean. We have the Atlantic, Pacific, Indian, Southern, and Arctic. There are also more smaller oceans called seas that are the Mediterranean, the Southern China Sea, and many others. Now we all know that you can't breathe underwater, so how do we explore the very deep depths? Well, I'm sure all of you know what a submarine is, or a boat even, but how does it really measure what's down there? Because you can't go all the way down. What we use is called sonar. It's where you shoot waves, and then they bounce back, and then you get to know what's down there, how deep things are. Sonar stands for sound, navigation, and ranging. How you analyze data from a sonar is the time it takes for the waves to go there and bounce back. It can be proportioned out to how far it is. What have we learned from sonar? Well, sonar has shown us that there are continental margins, tectonic plates, if you will, that divide up the actual land on Earth, even the part that's underwater. There are also volcanoes, mountains, basins. Pretty much anything you'd see above the water is also below the water. If you fill up a swimming pool that has bumps and ridges, it's exactly what you find in the ocean, only a lot bigger. We've also been able to drill into the ocean to see what's below it. And we've found many types of things in the sediment layers. Some of it's organic, some it's inorganic. Usually a lot of things dumped out by the main rivers, such as the Mississippi. Deposits that come together in lumps are called nodules. These nodules contain various types of elements such as iron, magnesium, nickel, and copper. Oceans aren't just made up of rocks and sediments that have reached the bottom of the ocean. There are also things such as dissolved gases. The same gases like oxygen, nitrogen, and even carbon dioxide that you find more commonly in the atmosphere are even more so prominent in the ocean. How do they get there, you ask? Well, sometimes rivers carry them in, sometimes underwater volcanoes shoot them up. Even underwater plants that cause photosynthesis obviously will release oxygen, but a lot of the oxygen just comes up and out of the ocean from more bubbles. It's not just when you jump in. With dissolved gases come also dissolved solids. And this is probably what you've looked up in the previous grades to see what ocean water really is made of. Because it's not just H2O. Granted, pure water is 96.5% of the ocean, but when you've tasted ocean water, you know it's quite salty. This is because the remaining dissolved solids are, of course, sodium, chlorine, and many other small trace elements which, like their name, suggests that there are very small amounts in the ocean, such as gold and zinc. And I really don't think about that. And no, collecting ocean water will not make you rich. It's just not enough of it to go around. Like most bodies of water, as you go deeper into the ocean, the temperature drops. But it also depends on how high or low of latitude you are. In tropical oceans, usually the ocean water is around 30 Celsius. But as you go up into the polar waters, it can go as low as negative 1.9 Celsius, which is the temperature that ocean water freezes because of the salt. And of course, between tropical and polar, it can range from 10 degrees Celsius to 20 degrees Celsius, depending on where you are and what season it is. As you reach about 250 meters below the water, it takes a hard shift colder as you go down. into the thermocline range, which ranges between 250 and about 500 meters. Once you get past that, you're sitting in about 3 degrees Celsius water, or even colder. You ever wondered why ocean water looks blue usually? Well, this is because it absorbs most of the colors of light, but blue tends to be reflected by most objects. So when it reflects it, it appears blue. As I mentioned very early in this video, there are many forms of life inside the ocean, ranging from microscopic organisms such as plankton to very large mammals such as whales. There are two main zones inside the ocean, the Benthic Zone and the Pelagic Zone. The Benthic Zone is the lower part of the ocean, and the Pelagic Zone is the upper part of the water. The Benthic Zone begins at the Intertidal Zone, which is where low tide and high tide interchange. Though because of the shifting waters, most organisms that live in the Benthic Zone exist in the zone right below it, which is called the Sublittoral Zone. Below the Sublittoral Zone is the Bathylic Zone, and that is where there's little or no sunlight that gets below or gets down there because of how dense the ocean waters become at that point. Below the Bathyal Zone is the Abyssal Zone, which of course is where the abysses are. It's located about 6,000 meters down and only contains very small organisms, such as sponges and worms. And finally, below the Bathyal Zone is the Hadal Zone. Now, we don't know much about the Hadal Zone as much as we know about the far reaches of the universe, but scientists still believe that there's not very much life there, due to the fact that even we, if we went down there, we would be crushed, just like most animals. A lot of marine life exists in the Pelagial Zone, but as you go down, less and less of marine life are there. It's perfectly possible, very expensive, to turn ocean water into fresh water in a process known as desalination. There are 3 methods of desalination. The first one is called distillation, in which you heat up the ocean water, which removes the salts. Next is freezing, which of course is when you freeze the ocean water because the frozen ocean water will not contain salts. And the third one is reverse osmosis distillation, which is when water at high pressure is sent through a membrane which blocks the salts but not the water going through it. The ocean is used by humans for many reasons. One, there are many good reserves of petroleum and other kinds of oil below the surface. You all remember the BP oil spill, I'm sure. But it's still very much worth it to drill into the ocean to obtain the gas to power cars and many other devices. The ocean is mined for materials previously mentioned for monetary gain and other manufacturing requirements. And of course, what many people know is getting food from the ocean. People fish as a sport, or people fish to feed their families and other people. Also, we can actually plant in shallow oceans, such as in the ones in the Caribbean, to grow plants that are able to grow underwater most of the time of their life. But with all this comes ocean water pollution. Now, I'm not going to give you a big environmental PSA about it, but it is becoming a growing problem with things such as the previously mentioned BP oil spill, which killed many marine life in the Gulf of Mexico, and other things like dumping into the ocean. If we kill everything, then how are we going to get gain from it? That's all I'm going to say about that. Large movement in the ocean are called currents. Ones that happen near or at the surface and are driven by wind are called surface currents. And they're controlled by 3 factors: air currents, Earth's rotation, and where the continents are located. The reason wind is able to control the ocean currents is because wind, because it is moving, has kinetic energy. And when it touches the ocean, it transfers kinetic energy, which can send ocean water moving many miles. There are constant global winds that blow throughout the entire Earth, such as trade winds and polar easterlies. The Coriolis Effect, created by Earth's rotation, causes air currents and subsequently ocean currents to curve and not go in a straight line. This can be taken advantage of by people sailing the ocean to grab onto currents so they don't have to use as much effort to get across to where they need to go. I'm sure you all mentioned the brief mention last grade about ocean waves. A wave, in its generic scientific definition, is when a gas, liquid, or solid has a periodic disturbance because of energy transmitted throughout it. We can determine the speed of waves by dividing wavelength by wave period, which is better known as frequency. While it may seem, because of the constant movement of waves, that the water it goes through actually moves, but this is a common misconception. The water itself doesn't move very much, but the molecules are changing energy constantly and very quickly depending. Waves can behave very erratically on the coastline. They can just form little breakers, which is when the wave comes up in big shore and crashes on the ocean and goes back. But there are also rip currents and undertows, which can rip people out towards shore or any object in the water. Very commonly, there are longshore currents, which can move parallel or at an angle towards the coastline and not straight on. Very violent breakers on the coastline are called tsunamis, which we all know can be very destructive because of the very tall wall of water that approaches and goes much farther than normal high tide and even low tide. The reason tides even exist are because of the moon's gravity affecting Earth. Water does not stay at a constant level above everywhere, even though we seem to be able to determine the depth of water in any area. As the moon orbits the Earth, it pulls the waters higher in some places and lower in others, stretching it almost, if you could see it as a circle. The sun can also change how much moon's gravity affects the tides, which can be seen at spring or fall or any sort of season. And also we can judge it from what part of the moon we can see. The depth of high tide or the time low tide will appear is never constant, but it can be judged quite well, but always because of fluctuation in gravity we'll never be sure of. And congratulations, I just taught you all chapters 23, 24, and 25 in a video that took a lot less time than watch your favorite episode of Jersey Shore or whatever you kids watch these days. I hope you enjoyed it. I had a lot of fun making it. See y'all later.